Today I am talking about odd and even functions. Your function f of x is said to be even if f of minus x is equal to fx. The function f of x is said to be even if f of minus x is equal to f of x. Example, if x is equal to x squared plus x to the power 4. Call this as equation 1. And to test whether this function is even or not, substitute x is equal to minus x. F of minus x is equal to minus x whole square plus minus x to the power 4. Wherever x is there, you have to substitute x is equal to minus x. So what happens? X square. Here, minus 1 to the power 4 plus 1 is x to the power 4. So let us call this as equation 2. So wherever x is there, substitute x is equal to minus x, then you are getting this. Whatever the result you got, you call that as equation 2. Observe whether equation 1 is equal to equation 2. Observe x squared plus x4, here also x squared plus x4. Therefore, equation 1 is equal to equation 2. Equation 1 is equal to equation 2, that means f of x is equal to f of minus x. Therefore, the function is even. Getting it clear? So, the function f of x is said to be even if f of minus x is equal to plus f of x. Now let us take a second example. One more example let us take. What is that? Another example, f of x is equal to cos of 3x, or say simply cos mx, right? So let us substitute x is equal to minus x. F of minus x is equal to cos m. Wherever x is there, I have to substitute x is equal to minus x. Cos of minus x. Now suppose f of x is cos mx plus say x square. Then what you are doing? Replace x by minus x whole square. So, given problem, this is the given problem. Call this as equation 1. Now, substitute x is equal to minus x. So, what happens? Cos of minus mx plus keep x is equal to minus x whole square. So, you know cos of minus theta is cos theta only. You know the formula. Cos of minus theta is equal to cos theta. So, therefore, cos of minus mx is cos mx. This minus x whole square is equal to plus x square. Now call this as equation 2. Observe equation 1, it is equal to equation 2. Equation 1 is equal to equation 2. So this implies the given function fx, that is this one, is even. Therefore, f of x is equal to even. Now we will take one more example. F of x is equal to sin mx, absolute value of sin mx. Right? Now we replace x by minus x. So this is absolute value of sin m into x is replaced by minus x. What do you mean by absolute value? Always it is positive. So therefore, absolute value of sin mx, it is equal to this only. This is sin of minus sin of mx. So this is same as this only. Or you can write it is equal to sin mx. Right? Equation 1 it is equal to equation 2. If I remove this absolute value of this, it is equal to sin mx only. Equation 1 becomes equal to equation 2. So therefore, given function fx is even. Right? Now let us go for the definition of odd function. Definition of odd function. Your function fx is said to be odd. The function fx is said to be odd if f of minus x, it is equal to minus 1 into fx. This is the definition of odd function. f of minus x, that is equal to minus 1 into fx. Now let us take some examples. Example. Suppose if I take f of x is equal to 3x cubed plus x. Now this is the given problem. I have to test whether this function is odd or even. Now let us replace x by minus x. So what I am doing? Always we are replacing x by minus x. Substitute x is equal to minus x. Then what happens? This is equal to 3 into, put x is equal to minus x whole cube, put x is equal to minus x. Simplify this. This is minus 3x cube, here minus 6. Call it as equation 2. So what I am doing always, whether it is even function or odd function, I don't know in the beginning. So therefore, what I am doing, put x is equal to minus x. When you put x is equal to minus x, simplify, call that as equation 2. Now, see, observe whether equation 1 is equal to equation 2. Equation 1, it is not equal to equation 2. Here, by seeing you can recognize. This is 3x cubed plus x. This is minus 3x cubed minus x. Equation 1 is not equal to equation 2. So therefore, what is the conclusion? Function is not even. So therefore, what I have to do next? What I have to do next? So I have to check whether the function is odd. To check whether the function is odd, what I do is I am computing minus 1 into fx. That is minus 1 into, what is the fx value? 3x cubed plus x. So call this as equation 3. So observe, what is this? Minus 3x cubed minus x. Observe, minus 3x cubed minus x. So what is equation 2? F of minus x. What is equation 3? Minus fx. So observe the point. Equation 2 is equal to equation 3. So therefore, function is odd. I repeat. Observe. This is the given problem. This is the given problem. I have to test whether the function is odd or even. So what I do? Replace x by minus x. Okay. 3 into, put x is equal to minus x. Here put x is equal to minus x. So then what are you getting? Minus 3x cubed, here minus x. So this is equation 2. Now check whether equation 1, it is equal to equation 2. Equation 1, it is not equal to equation 2. Observe the point. Equation 1 is not equal to equation 2. Therefore, function is not even. In order to check whether the function is odd or not, what I do? I am taking minus 1 into f of x. That is minus 1 into fx. Fx means this given problem 3x cubed plus x. So what is this? Minus 3x cubed minus x. So this result is equal to this. So therefore equation 2 it is equal to equation 3. That means f of minus x is equal to minus 1 into fx. When equation 2 becomes equal to equation 3, then the function is odd. So let us take one more example. F of x is equal to sin x plus x cubed. Now let us substitute x is equal to minus x. So f of minus x is equal to sin of minus x. Put x is equal to minus x whole. Given problem is equation 1. Simplify this, put x is equal to minus x. So if I put x is equal to minus x, minus sin x, here minus x cubed. Call this as equation 2. Now observe, this equation 1 is not equal to equation 2. Let us write clearly, equation 1 is not equal to equation 2. Therefore, function is not even. Now let us test whether the function is odd. In order to test whether the function is odd, I compute minus 1 into fx. That is minus 1 into fx. Fx means this given problem. That is sin x plus x cubed. So therefore this is minus sin x minus x cubed. So this is equation 3. Now observe, equation 2, it is equal to equation 3. Equation 2 is equal to equation 3. Equation 2, it is equal to equation 3. Therefore, function is R. It is quite clear. So this is how we test whether a function is R or even. Now let us talk about Fourier series of odd and even function. We are talking about Fourier series of odd and even function. Now what is the Fourier series? Fx is equal to a naught by 2 plus sigma an cos of n by x by l, sigma an cos of n by x by l, n varying from 1 to infinity, plus sigma bn into sin of n by x by l, n varying from 1 to infinity. When given a function fx is defined in the interval alpha to alpha plus 2l, then Fourier series is given by a naught by 2 plus sigma an cos n by x by l plus sigma bn sin n by x by l. You are finding a naught, an, bn, and later you are substituting. This is the Fourier series. Now suppose I am talking about if a function fx is even, if a function fx is even in the interval minus l plus l. The interval should be minus l plus l. If a function fx is even in the interval minus l plus l, then bn becomes 0. Then bn becomes 0. Then what remains? Only a naught and a remains. You know the formula for a naught. What is a naught? A naught. Or you can write like this: a naught is equal to n for a naught. Then the formula for a naught and a n is a naught is equal to 2 by l integral 0 to l fx dx. an is equal to 2 by l integral 0 to l fx into cos of n by x by l dx. This is the formula. So remember clearly, not only the function is given, it should be in the interval minus l plus l. Suppose if I take, say, fx is equal to x square, this is given. The interval should be of the form minus 2 plus 2, or minus 1 plus 1, or minus 10 plus 10. Suppose if it is like this, minus 10, 1, then this formula is not applicable. It should be always in the form minus n plus n. Minus 1 plus 1. Right? Minus 2 plus 2. Minus 3 plus 3. So, in order to apply this formula, two conditions are necessary. First, function should be given. Second, it should be of the form minus n plus n. Now, so suppose if the function fx is given and if it is defined in the interval minus n plus l, then what happens is a naught is given by this formula 2 by l 0 to l fx dx. A n is given by 2 by l 0 to l fx cos n by x by l dx. Now let us take the next case. That is, if the function fx is number 1 odd, defined in the interval minus l plus l, that is number 2. Or simply I will say, if a function fx is odd, defined in the interval minus l plus l. If a function fx is odd, defined in interval minus l plus l, then the Fourier series is given by fx is equal to bn sin n by x by l. In the first case, a naught by 2 plus sigma an cos n by x by l. When the function is even. When the function is odd, only bn remains. A naught an becomes 0. Remember, If a function fx is odd, in the interval minus L plus L, a0 becomes 0, an becomes 0. Only this bn remains. What is that bn? Bn is equal to, write down the formula, 2 by L integral 0 to L fx into sin of L by x by L dx. Are you able to see the board? Let us see. Yes, it is clear. Suppose if the function fx is even, then bn becomes 0, a0 an remains. I have already given the formula for a0 an. So this is how the Fourier series is obtained whenever a function is odd in the interval minus L plus L, whenever a function is even in the interval minus L plus L. Okay, let us stop at this point. In the next class, we are talking about problems